We did this one, these two, the impossible one, the fifths, the tenths, and the 15ths. All right. Number 14. The probability of blue then green. Probability of blue multiplied by probability of green after blue. Probability of blue is 3. There's 3 blue marbles, and there's 4, 5, 6, 7, 8, 9 marbles altogether. So there's a 3/9 probability of blue. Now you have to remember, just cover up one of the blue marbles. It says we do not replace it, so I cover up one blue marble. I no longer have 9 marbles in the bag, I have 8 marbles. And how many of them are favorable outcomes? The 2 greens. So 2 out of 8, 2/8 for the second probability. 2/8 simplifies to 1/4, 3/9 simplifies to 1/3, and we get a probability of 1/12. Cross off the 12th right there. 15. Probability of green then red. Probability of green multiplied by probability of red after green. Probability of green is 2 out of 9. There are two favorable outcomes and 9 marbles in the bag. Once one of those greens is gone, you can see someone kind of marked out the green here. And I didn't get access to the resource until after that had been done, but in any case, we just pretend that green's gone. You've got 4 reds in the bag, but only 8 marbles because that first green has been removed. So there are 4/8, which of course is 1/2, and then these 2's will cancel, and you get a probability of 1/9. Number 16 says probability of green then green. 16 is probability of green multiplied by probability of green after green. The probability of the first green is 2 out of 9, so 2/9. If we don't replace that green, there's only 1 green left, but there's also only 8 marbles left. So the 2 and the 8 have a common factor of 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. And so we get a probability of 1/36, very unlikely to get green then green without replacing the first green. It's hard to get 2 of them if you do replace the first green. Green has the fewest number of marbles in the bag in the first place. 1/36. Number 17. Probability of green then not green. Probability of green multiplied by probability of not green after picking a green. Probability of green, there's 2 favorable outcomes and 9 marbles in the bag, so 2/9. Now, same thing, cover up 1 green marble, because that green that we picked the first time did not get replaced. What's the probability of not picking a green? The probability of picking a green is 1/8. The probability of not picking a green must be the complement, or 7/8, or you could just count them. There are 1, 2, 3, 4, 5, 6, 7 marbles that are not green. All the blues and all the reds would count, so 7 out of 8, or 7/8, very likely to pick a not green. The 2 and the 8 have a common factor of 2. That becomes a 1, that becomes a 4. And so the probability of picking a green, not replacing it, and then picking a marble that's not green is 7/36. Still pretty low probability, because even though the second event is highly likely, the first event wasn't very likely, and so overall it's not likely. Just wondering about something. Yeah, okay. 7/36. There it is. Number 18. Probability of red multiplied by probability of blue after red. Red is nearly 50-50. There's 4 reds and 9 marbles. It's a little bit less than 1/2, 4/9. And then cover up 1 red with your thumb. You can then you can see there's 8 remaining marbles, and 3 of them are blue. So 3/8. The 3 and the 9 have a common factor of 3. The 4 and the 8 have a common factor of 4. And so you end up with 1/6. 1/6. 19, probability of red, then not blue. 19, probability of red multiplied by probability of not blue after picking the red and not replacing it. The probability of getting red with the first pick is, of course, 4/9, just like the last problem. Then cover up one red with your thumb. The probability of picking a marble that's not blue. Well, the remaining 3 red marbles would be favorable outcomes, as would the 2 green marbles. So you have 5 not blue marbles of the remaining 8 marbles. So 5/8 here. The 4 and the 8 have a common factor of 4. And that's it for common factors. So we get 5/18 right there. Number 20, probability of blue then blue would equal the probability of blue multiplied by the probability of blue after blue. The probability of blue is 3 of the 9, so 3/9. I'm going to simplify that to 1/3 right away. Now cover up one blue marble. The probability of getting a blue marble on the second pick, if one of them is out of the bag, would be 2 favorable outcomes out of 8 possible outcomes. So 2/8, aka 1/4, and so we get 1/12 right there. 21, probability of not blue then not blue. Probability of not blue multiplied by probability of not blue after getting a marble that's not blue. The chance of getting a marble that's not blue on the first pick, just count up all the favorable outcomes. The 2 greens and the 4 reds would be a total of 6 marbles that are not blue. So you have a 6 out of 9 chance of getting a marble that's not blue. Now, you could cover up one red or one green, it doesn't matter, as long as you cover up a marble that's not blue. Let's just pretend this green is covered up. The chance of getting the second marble without replacing the first, there's only 1, 2, 3, 4, 5 not blue marbles now, the 1 green and the 4 reds. So that's 5 out of 8, because again, that first unblue marble would no longer be in the bag, so that reduces the total number of possible outcomes by 1 as well. 6/9 is 2/3, and 2 and 8 have a common factor of 2, so you end up with 5/12. Now, I don't like my chances of remembering this. I know what to do. We'll do the next slide. We'll do the last ones, and then we'll come back and just put them on here and work from here. That'll work.